Alright, so this video is about trig ratios. As you can see on the screen, a trigonometric ratio is a ratio of the lengths of two sides in a right triangle. We use it to find missing sides if we know at least one acute angle in one side, or to find one of the acute angle measures if we know at least two of the side lengths. SOHCAHTOA is an acronym to help us remember how all of the trig ratios are related. So in my triangle here, I'm going to have triangle A, B, C. Angle C is my right angle right there. And so the side across from angle C is lowercase c, the side across from angle A is lowercase a, and the side across from angle B is lowercase b. So what we're going to do, SOHCAHTOA stands for sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. So we're going to start out, if we have sine of angle A, that means it's going to be the opposite leg from angle A over the hypotenuse. So in this case, if you look, opposite of angle A is the lowercase a over there. So A over, and then the hypotenuse in this triangle is C. So sine of angle A equals A over C. If we look at cosine of angle A, it's the adjacent leg to A over the hypotenuse. So adjacent to angle A is side B, so I get B over the hypotenuse, which is C. Notice the hypotenuse is also adjacent to angle A, but if you look down at the bottom of this slide, it says that the hypotenuse will never be the adjacent or opposite side. It's just the hypotenuse, period. When we're talking about adjacent or opposite sides, we're always talking about the legs. And then the last one is tangent of A, and tangent of A is going to be the opposite leg over the adjacent leg. So in this case, opposite of A is A and adjacent is B. So tangent of A equals A over B. Alright, so now we're going to look at an example. So in our example, we have this triangle. We know it's a right triangle, and we're trying to find one of the side lengths. We know one of the acute angle measures. So what I do here, so this is my given, and our unknown is to find the value of x. And so what I'm going to do is I'm going to label what I know. Here's my angle that I know something about, and so the x is adjacent to it. So I'm going to label that as adjacent. And then the 6 over here is my hypotenuse. So then I think about my trig ratios. Which one deals with adjacent and hypotenuse? So I go back to SOHCAHTOA. So adjacent and hypotenuse is this one. So my equation is going to be cosine of the angle equals adjacent over hypotenuse. So now I can substitute in what I know. Cosine of angles of 73 equals, the adjacent is my x, hypotenuse is 6. So now I have my equation. I need to solve for x. Well, if you look, the x is connected to the 6 by division, so we're just going to multiply both sides by 6 to get the x by itself. So now I have 6 times cosine of 73 equals x. And we're going to put that into the calculator. I'm going to show you more in class how to use the calculator to solve this. One thing you have to remember though is your calculator always needs to be in degree mode, and I'll show you how to do that in class. So 6 times cosine of 73, when we plug that into the calculator we get a decimal, and we're going to round it to 1.75, so x equals 1.75. So now in class you actually get to start using a calculator and decimals. How about that? Alright, so in the last example we solved for a missing side length. In this example we're going to solve for the missing angle down here. Let's go ahead and call this angle A. So this is our given. Our unknown is we want to find the measure of angle A. Once again, in my picture I'm going to label what I know. So the 40 is across from angle A, so that's going to be opposite. And the 42 is across from the right angle, so of course that's the hypotenuse. So I keep in mind so, ka, toa. And I look, I have opposite and hypotenuse. Opposite and hypotenuse, that's the sine. So my equation is sine of the angle equals opposite over hypotenuse. So when I substitute in, I do sine of the angle, where my angle in this case is A, that's what I'm trying to solve for, equals, opposite is 40, and the hypotenuse is 42. Now, I have to get A by itself. Well, I have that sign there. The sign is kind of like an operation, and so we know if it was something multiplied by A, we would divide. If it was added, we would subtract, and so on. We do the opposite operation, or the inverse operation. So what we're going to do is take the inverse of sine. So we do sine -1, that represents inverse of sine A. And whatever we do to one side, we have to do to the other. So on the other side, we do inverse sine of 40 over 42. So the inverse sine and sine, those two like negate each other, and so we're left with A equals, and then you'll plug this into the calculator, and I'll show you in class how to do it. And when we solve for that, angle A comes out to be 72.25 degrees. So that's the measure of angle A. And that's it.